An Internet media type is a standard identifier used on the Internet to indicate the type of data that a file contains. Common uses include the following: email clients use them to identify attachment files, web browsers use them to determine how to display or output files that are not in HTML format, search engines use them to classify data files on the web. A media type is composed of a type, a subtype, and 0 or more optional parameters. As an example, an HTML file might be designated text HTML. Charset equals UTF-8. In this example, text is the type, HTML is the subtype, and charset equals UTF-8 is an optional parameter indicating the character encoding. IANA manages the official registry of media types. The identifiers were originally defined in RFC 2046, and were called MIME types because they referred to the non-ASCII parts of email messages that were composed using the MIME specification. They are also sometimes referred to as content types. Their use has expanded from email sent through SMTP, to other protocols such as HTTP, RTP and SIP. New media types can be created with the procedures outlined in RFC 6838. Limitations: Internet media types are often used as part of a communication protocol between two applications. In this context, Internet media type specifiers experience several problems. The first problem is the ability of the source application to correctly determine an Internet media type for a piece of content. Many applications attempt to heuristically classify a file using its file name extension or with magic numbers. Neither approach is perfect, and may incorrectly classify a content's media type. Incorrect file name extension: a file name extension classifier will report an incorrect media type. For instance, some applications incorrectly give rich text format files the doc file extensions, instead of the correct ATF extension. No file name extension: a file name extension classifier will report no media type, or will report a catch-all type such as application Octet stream. Files without extension are common on Unix systems. File name extension collisions: when multiple formats use the same file name extension, a file name extension classifier will choose one media type arbitrarily. For instance, both Microsoft Word templates and Graphis graph files use the extension .dot. Ambiguous container formats: a magic number classifier may give a correct, though non-specific, media type, thus preventing a meaningful interpretation of the content. For instance, Office OpenXML format and Java executable are both implemented internally as a zipped archive. A magic number system may classify such files as application zip instead of the more specific type. Similar problems occur between XML and application formats implemented on top of XML. Ambiguous magic numbers: an attacker can create a file which is identified simultaneously as two separate Internet media types. For instance, the internal structure of a GIF makes it both a valid GIF image and Java executable. The second problem is the destination application's ability to trust the Internet media type reported by the sender. As above, the Internet media type is incorrect in some circumstances, and must be treated with skepticism. As early as 2002, the W3C unambiguously warned that it is a serious error if Internet media type is incorrect, and that software should not attempt to guess a correct media type. Nonetheless, software engineering principles encourage software that forgives a certain degree of malformed input, and user experience suffers when software fails to correctly interpret the content. Consequently, the many destination applications are designed to attempt recovery from such errors and identify a correct media type. The destination application has no more knowledge of the content than the source application, and attempts to infer the media type at the destination are equally difficult. This can lead to incompatibilities between source and destination applications, and in the worst case, security vulnerabilities such as the Gipher attack or cross-site scripting attacks. Advanced content sniffing approaches have been proposed to balance interoperability and security in such situations. Naming: media type consists of top-level type name and subtype name, which is further structured into so-called trees. media types can optionally define companion data, known as parameters. Top-level type name/subtype name, A. Parameters, top-level type name/tree. Subtype name, plus suffix, A. Parameters, the currently registered top-level type names are, application, audio, example, image, message, model, multi-part, text, video. Subtype name typically consists of a media type name, but it may or must also contain other content, such as tree prefix, producer's name, product name or suffix, according to different rules in registration trees. Examples, image SVG plus XML, application VND Oasis Open Document Text, text plain. Charset equals UTF-8, video MP4. Codecs equals AVC 1.640028. Registration trees, all media types should be registered using the IANA registration procedures. For the efficiency and flexibility of the media type registration process, different structures of subtype names can be registered in registration trees that are distinguished by the use of faceted names, for example subtype names that begin with a tree. Prefix. Currently the following trees are created: standard, vendor, personal or vanity, unregistered X. These registration trees were first defined in November 1996. New registration trees may be created by IETF standards action, for external registration and management by well-known permanent organizations. Standards tree, media types in the standards tree do not use any tree facet. Registrations in the standards tree must be either associated with IETF specifications approved directly by the IESG, or registered by an IANA-recognized standards-related organization, type/media type name, plus suffix. Examples, application XHTML plus XML, image PNG, vendor tree. Vendor tree is used for media types associated with publicly available products. It uses VND. Facet. The terms vendor and producer are considered equivalent in the context. Industry consortia as well as non-commercial entities can register media types in the vendor tree. A registration in the vendor tree may be created by anyone who needs to interchange files associated with some software product or set of products. However, the registration belongs to the vendor or organization producing the software that employs the type being registered, and that vendor or organization can at any time elect to assert ownership of a registration done by a third party. Type/VND. Media type name, plus suffix used in the case of well-known producer, type/VND. Producer's name followed by media type name, plus suffix producer's name must be approved by IANA, type/VND. Producer's name followed by product's name, plus suffix producer's name must be approved by IANA. Examples, application VND Miss Excel, application VND Oasis Open Document Text for Oasis Open Document Text, application VND Etsy ASIC S plus zip for ETSIASIC, personal or vanity tree. Personal or vanity tree includes media types created experimentally or as part of products that are not distributed commercially. It uses PRS. Facet. Type/PRS. Media type name, plus suffix, unregistered X. Tree, the X. Tree may be used for media types intended exclusively for use in private, local environments and only with the active agreement of the parties exchanging them. Types in this tree cannot be registered. According to RFC 6838, any use of types in the X tree is strongly discouraged. Media types with names beginning with X are no longer considered to be members of this tree since January 2013. According to the previous version of RFC 6838, obsoleted RFC 2048, it should rarely, if ever, be necessary to use unregistered experimental types, and as such use of both X and X forms is discouraged. Previous versions of the RFC, RFC 1590 and RFC 1521 stated that the use of X notation for the subtype name may be used for unregistered and private subtypes, but this recommendation was obsoleted in November 1996. All media types should be registered using the simplified IANA registration procedures for vendor and personal trees or using the standards procedure for standards tree. Media types that have been widely deployed without being registered should be, if possible, re-registered with a proper faceted subtype name. If this is not possible, the media type can, after an approval by both the media types reviewer and the IESG, be registered in the proper tree with its unfaceted name. Type/X. Media type name, plus suffix, suffix. Suffix is an augmentation to the media type definition to additionally specify the underlying structure of the media type. Media types that make use of a named structured syntax should use the appropriate IANA registered plus suffix for that structured syntax when they are registered. Unregistered suffixes should not be used. Structured syntax suffix registration procedures are defined in RFC 6838. The currently registered suffixes are, plus XML, plus JSON, plus bear, plus dir, plus fast and facet, plus WBXML, plus zip, plus kba, plus XML suffix is defined since January 2001. Formal registration of plus XML suffix and other suffixes is defined since January 2013. List of common media types. IANA manages the official registry of media types. Among others, it includes the following types: type application, for multipurpose files, application atom plus XML, atom feeds, application Dart, Dart files, application ECMAScript, ECMAScript JavaScript. Defined in RFC 4329, application EDIX12, EDIX12 data. Defined in RFC 1767, application EDIFACT, EDIFACT data. Defined in RFC 1767, application JSON, JavaScript object notation JSON. Defined in RFC 4627, application JavaScript, ECMAScript JavaScript. Defined in RFC 4329, it is not accepted in IE8 or earlier. Text JavaScript is accepted but it is defined as obsolete in RFC 4329. The type attribute of the script tag in HTML5 is optional. In practice, omitting the media type of JavaScript programs is the most interoperable solution, since all browsers have always assumed the correct default even before HTML5, application Octet stream, arbitrary binary data. Generally speaking, this type identifies files that are not associated with a specific application. Contrary to past assumptions by software packages such as Apache, this is not a type that should be applied to unknown files. In such a case, a server or application should not indicate a content type, as it may be incorrect, but rather, should omit the type in order to allow the recipient to guess the type. Application OGG, a multimedia bitstream container format. Defined in RFC 5334, application PDF, portable document format. PDF has been in use for document exchange on the Internet since 1993. Defined in RFC 3778, application PostScript, PostScript. Defined in RFC 2046, application RDF plus XML, resource description framework. Defined by RFC 3870, application RSS plus XML, RSS feeds, application SOAP plus XML, SOAP. Defined by RFC 3902, application font WOFF, Web Open Font Format. Application XHTML plus XML, XHTML. Defined by RFC 3236, application XML, XML files. Defined by RFC 3023, application XML DTD, DTD files. Defined by RFC 3023, application XOP plus XML, XOP, application ZIP, ZIP archive files. Registered, application GZIP, GZIP, defined in RFC 6713, application example, example in documentation, defined in RFC 4735, application XNACL, native client web module, application XPNACL, Portable Native Client Web Module, type Audio, for audio. Audio Basic, I1/4 law audio at 8 kHz, 1 channel. Defined in RFC 2046, Audio L24, 24-bit linear PCM audio at 8 to Euro 48 kHz, 1 N channels. Defined in RFC 3190, Audio MP4, MP4 audio, Audio MPEG, MP3 or other MPEG audio. Defined in RFC 3003, Audio OGG, OGG for Bs, Speaks, FLAC and other audio. Defined in RFC 5334, Audio Opus, Opus Audio, Audio VOBs encoded audio. Defined in RFC 5215, Audio VNDRN Rel Audio, Real Audio. Documented in Real Player Help, Audio VND Wave, WAV Audio. Defined in RFC 2361, Audio WEBM, WebM Open Media Format, Audio Example, Example in Documentation, defined in RFC 4735, Type Example, for example types in documentation, not for real code, Example, defined in RFC 4735, Type Image, Image GIF, GIF Image. Defined in RFC 2045 and RFC 2046, Image JPEG, JPEG JFIF Image. Defined in RFC 2045 and RFC 2046, Image PJPEG, JPEG JFIF Image. Associated with Internet Explorer. Listed in MIS 775147, V equals versus 85, Progressive JPEG, initiated before global browser support for progressive JPEGs. Image PNG, Portable Network Graphics. Registered, defined in RFC 2083, Image SVG plus XML, SVG Vector Image. Defined in SVG Tiny 1.2 Specification Appendix M, Image VND DJVU, DJVU Image and Multipage Document Format. Image Example, Example in Documentation, defined in RFC 4735, Type Message, Message HTTP, defined in RFC 7230, Message IMDN plus XML, IMDN Instant Message Disposition Notification. Defined in RFC 5438, Message Partial, Email. Defined in RFC 2045 and RFC 2046, Message RFC 822, Email. Email files, MIME files, MHT files, MHTML files. Defined in RFC 2045 and RFC 2046, Message Example, Example in Documentation, defined in RFC 4735, Type Model, for 3D models. Model Edges, IGS files, IGES files. Defined in RFC 2077, Model Mesh, MSH files, Mesh files. Defined in RFC 2077, Silo files, Model VRML, WRL files, VRML files. Defined in RFC 2077, Model X3D plus Binary, X3D ISO standard for representing 3D computer graphics, X3DB binary files, Never Internet Assigned Numbers Authority Approved, Model X3D plus Fast and Facet, X3D ISO standard for representing 3D computer graphics, X3DB binary files, Model X3D VRML, X3D ISO standard for representing 3D computer graphics, X3D VVRML files, Model X3D plus XML, X3D ISO standard for representing 3D computer graphics, X3D XML files, Model /example, Example in Documentation, defined in RFC 4735, Type Multipart, for archives and other objects made of more than one part. Multipart Mixed, MIME Email. Defined in RFC 2045 and RFC 2046, Multipart Alternative, MIME Email. Defined in RFC 2045 and RFC 2046, Multipart Related, MIME Email. Defined in RFC 2387 and used by MHTML, Multipart Form Data, MIME Web Form. Defined in RFC 2388, Multipart Signed, defined in RFC 1847, multi-part encrypted, defined in RFC 1847, multi-part example, example in documentation, defined in RFC 4735, typed text, for human-readable text and source code. Text CMD, commands. Subtype resident in Gecko browsers like Firefox 3.5, text CSS, cascading style sheets. Defined in RFC 2318, text CSV, comma-separated values. Defined in RFC 4180, text example, example in documentation, defined in RFC 4735, text HTML, HTML. Defined in RFC 2854, text JavaScript, JavaScript. Defined in and made obsolete in RFC 4329 in order to discourage its usage in favor of application JavaScript. However, text JavaScript is allowed in HTML4 and 5 and, unlike application JavaScript, has cross-browser support. The type attribute of the script tag in HTML5 is optional and there is no need to use it at all since all browsers have always assumed the correct default. Text plain, text dual data. Defined in RFC 2046 and RFC 3676, text RTF, RTF. Defined by Paul Lindner, text VCARD, VCARD. Defined in RFC 6350, text VND ABC, ABC music notation. Registered, text XML, extensible markup language. Defined in RFC 3023, type video, for video. Video RV, covers most Windows-compatible formats including RV and DivX. Video example, example in documentation, defined in RFC 4735, video MPEG, MPEG-1 video with multiplexed audio. Defined in RFC 2045 and RFC 2046, video MP4, MP4 video. Defined in RFC 4337, video OGG, OGG Theora or other video. Defined in RFC 5334, video QuickTime, QuickTime video. Registered, video WEBM, WebM Matroska-based open media format, video X Matroska, Matroska open media format. Video XMIS WMV, Windows Media Video. Documented in Microsoft KB 288102, Video XFLV, Flash Video, List of common media subtype prefixes, prefix VND, for vendor-specific files. Application VND Debian Binary Package, DEB, a software package format used by the Debian project. Registered. Application VND Oasis Open Document Text, Open Document Text. Registered, Application VND Oasis Open Document Spreadsheet, Open Document Spreadsheet. Registered, Application VND Oasis Open Document Presentation, Open Document Presentation. Registered, Application VND Oasis Open Document Graphics, Open Document Graphics. Registered, Application VND Miss Excel, Microsoft Excel files, Application VND Open XML formats Office Document Spreadsheet Sheet, Microsoft Excel 2007 files, Application VND Miss PowerPoint, Microsoft PowerPoint files, Application VND Open XML formats Office Document Presentation Microsoft PowerPoint 2007 files, Application VND Open XML formats Office Document Word Processing Document, Microsoft Word 2007 files, Application VND Mozilla Zool plus XML, Mozilla XUL files, Application VND Google Earth KML plus XML, KML files, Application VND Google Earth KMZ, KMZ files, Application VND Android Package Archive, for download APK files. Application VND MISCPS Document, XPS Document, Text VND ABC, ABC Music Notation. Registered, prefix X, for experimental or non-standard files. Deprecated by RFC 6648. Application X7Z Compressed, 7-zip compression format, Application X Chrome Extension, Google Chrome Chrome OS Extension, App, or Theme Package, Application XVi, device-independent document in DVI format, application X font TTF, true type font no registered MIME type, but this is the most commonly used, application X JavaScript, application X LaTeX, LaTeX files, application X MPEG URL, M3U8 variant playlist, application X RAR compressed, RAR archive files, application X Shockwave Flash, Adobe Flash files for example with the extension SWF, application X Stuffit archive files, application X tarball files, application /x www form encoded data. Documented in HTML 4.01 specification, section 17.13.4.1, application X XP install, add-ons to Mozilla applications, Audio X Arc audio files, Audio X CAF, Apple CAF audio files, Image X XCF, GIMP image file, Text X GWTRPC, Google Web Toolkit data, Text X JQUERYTMPL, jQuery template data, Text X Markdown, Markdown formatted text, application X PKCS12, a variant of PKCS standard files, see also, XML and MIME, MIME types file, content sniffing, references. External links, IANA MIME media types list, IANA character sets, RFC 2045, RFC 2046, multipurpose Internet Mail extensions, Parts 1 and 2, RFC 4288, media type specifications and registration procedures.